section, we will be working with the general form of the equation of a line. Now, so far, we've been working with what's called slope-intercept form. And slope-intercept form has the equation y equals mx plus b. This is very, very handy because just by looking at this equation, m is the slope, b is the y value or the output value of the vertical intercept. So just by looking at the equation, you have the slope and the y-intercept, which is very, very nice, especially when you're wanting to graph the linear function. And of course, x represents the input, and y represents the output. Now, the general form of a linear equation still describes a linear function. It still defines a line, but it looks very, very different. The x is still going to be the input value. The y is still going to be the output variable. But the other letters are just constants. A is not usually going to be the slope. B is not going to have any direct bearing on the graph. And C is probably not going to be the y-intercept. These are going to be just constants. I'm just going to write A, B, C are just constants. You can't just look at this and automatically tell what the slope is, what the y-intercept is. You're going to have to do a little bit of work whenever you're given a linear equation in general form. So example 1, you're given 3x minus 5y equals 30. Now, a nice first step, since we are so familiar with slope-intercept form, is to start out by rewriting this in slope-intercept form. Then we can automatically identify the slope, the vertical intercept, and so forth. So in order to do that, let me just rewrite the equation right here. 3x minus 5y equals 30. We want to solve this equation for y in terms of x. That will effectively put it into slope-intercept form. So I'm going to start by subtracting 3x from both sides. 3x minus 3x goes away, and we're left on the left-hand side with negative 5y equals 30 minus 3x. Those are not like terms, so you can't combine them. I'm just going to write them out on the same line. So 30 minus 3x. And then we have to divide out this negative 5. So we have to divide everything on the right-hand side by negative 5. On the left, the negative 5's cancel and leave you with just y equals 30 divided by negative 5 is negative 6. Minus 3x divided by a negative 5 is going to give us plus 3/5 x. And you could leave your answer like this. This is absolutely fine. Or you could switch it around a bit. Y equals 3/5 x minus 6. Either one of these is correct. Now part B is asking you to identify the slope. Now that we have this linear equation in slope-intercept form, it's really easy to pick out the slope. So we have y equals 3/5 x minus 6. Just by looking at this, the slope is 3/5. Part C, determine the vertical intercept. Again, if it's already in slope-intercept form, this is very, very easy. So we have y equals 3/5 x minus 6. Just by looking at this, there's the vertical intercept. The vertical intercept, it has to be an ordered pair. So 0, negative 6. Now, if you don't already have this equation in slope-intercept form, you can also find the vertical intercept just the way it is from general form. Remember, the trick to finding a vertical intercept is to set x or the input, equal to 0, solve for the output, or y. That is just in general what you need to do to find the vertical intercept. So if you want to use the equation that we started with, we had 3x minus 5y equals 30. Replace x with 0, so 3 times 0 minus 5y equals 30. 3 times 0 is 0, so over here we just have negative 5y equals 30. Divide both sides by negative 5, and you wind up with y equals negative 6, which as an ordered pair, there's 0, negative 6, which is the same thing that we got over here on the left. So it's just a different way of finding it. Now part D, we're asked to determine the horizontal intercept. And this, if we were starting from slope-intercept form, y equals, there's 3/5 x minus 6, we couldn't just pick this out of the equation. We had to do a little bit of work. Remember, you had to set y equal to 0 and solve for x. So this became 0 equals 3/5 x minus 6. Adding 6 to both sides, you wind up with 6 equals 3/5 x. You want to get rid of the 3/5, so multiply both sides by 5/3. And you wind up with, on the right-hand side, everything cancels, leaves you with x equals 5 times 6 is 30 thirds, which reduces to 10. So x is equal to 10, and your x-intercept, or horizontal intercept, is 10, 0. All right, you could also get this directly from general form without going through slope-intercept at all. And the trick is just the same. Here you're going to set y equal to 0, solve for x. You're just going to start with the equation in general form. So 3x minus 5y equals 30. That's what you're starting with. So 3x minus 5, replacing y with 0, equals 30. So 3x minus 5 times 0 is 0. So just 3x equals 30. Divide by 3, divide by 3, and you get x is equal to 10, which is, same as before, 10, 0. All right, now before we leave this example, I want to return to Part B. Part B is where we were asked to determine the slope of the line. Now, given in general form, you can't just look at it and pick out the slope, but we did this by first changing it into slope-intercept form and then identifying the slope from there. Once we have the intercepts, however, once we have the vertical intercept and the horizontal intercept, we can go back and find the slope without ever having to change general form into slope-intercept form. So let me just come back up here, draw a little line. Once we have these intercepts, we have 10, 0, and 0, negative 6. Use the slope formula. M equals y2 minus y1 over x2 minus x1, so negative 6 minus 0 over 0 minus 10 equals negative 6 over negative 10, which reduces to 3/5. So the slope, M, is equal to 3/5, which is the same thing we found before. It's just a different way of going about it.